You're living inside something so small, it doesn't even show up on the real map of the universe. Sounds impossible, right? But if Earth shrank to the size of a tiny ball in your hand, Jupiter would explode into something massive beside it. And the Sun? It wouldn't even fit in the frame. You'd have to step back, then back again, until it towers like a moving wall. But here's the strange part. Even that giant Sun is basically nothing. So what happens when we keep scaling up? Because once you start this journey, there's no going back. Every step breaks your sense of size. Every comparison feels wrong. And somewhere along the way, reality stops making sense. Let's start simple. Earth feels huge. Oceans, continents, billions of people. But compared to Jupiter, it's microscopic. You could fit over 1,000 Earths inside that gas giant. 1,000 worlds gone. And that's not even the craziest part. Jupiter isn't just big. It's a protector. Its gravity acts like a cosmic shield, pulling in deadly comets before they ever reach us. Without it, life here might never have survived. So here's the question. If Jupiter is this powerful, what exists beyond it? Because out there, 470 light years away, something doesn't behave like a normal planet. Something too big, too unstable, too wrong. And this is where it gets weird. What if a planet never became a planet at all? What if it almost became a star, but failed? Out there in deep space exists a monster called Rox 42b, and it shouldn't exist the way it does. At first glance, it's just another gas giant. Bigger than Jupiter, wider than anything in our solar system. But the moment you look closer, something breaks. Because gas giants and stars are made of the same ingredients. Hydrogen, helium, nothing special. So what's the difference? Mass. If a planet gets heavy enough, about 13 times Jupiter, it ignites. Fusion begins. And just like that, it becomes a star. But Rox 42b stops just short. And that's where things change. It's too big to be a normal planet. Too small to be a star. Which raises a disturbing possibility. It may have skipped being a planet entirely. Instead of forming slowly from dust, it may have collapsed instantly from a cloud, like a star does. But it failed to ignite. A cosmic misfire. A failed star, trapped in planetary form. But that's not even the craziest part. Deep inside, its core still burns. Not bright like a star, but glowing. Hot. Angry. Leftover heat from its violent birth. Now ask yourself, if something this unstable exists, what happens when we scale up again? Because planets are limited. They can only grow so big before physics stops them. So what comes next? Stars. And this is where everything you thought was big gets completely destroyed. The sun feels infinite, blinding, massive, untouchable. It holds 99.86% of everything in our solar system. Every planet, every asteroid, every comet, just leftover crumbs orbiting it. But here's the strange part. The sun isn't special. It's average. And that should scare you. Because just beyond our neighborhood are stars that make the sun look like a spark. Take Sirius A. It's brighter than any star in our sky, not because it's the biggest, but because it's close. Still, it's nearly twice the size of our sun. But that's just the beginning. Because stars don't stay stable forever. When they begin to die, they expand. Slowly, quietly, then violently. And this is where it gets weird. Some stars swell so much, they would swallow entire planets whole. Mercury? Gone. Venus? Gone. Earth? Maybe gone too. But that's not even the craziest part. There are stars so large, if placed where our sun is, their surface would stretch past Mars, even toward Jupiter. These are red giants. Bloated, dying, unstable, and they're only a phase. So here's the question. If dying stars grow this large, what does the final stage look like? Because the next step doesn't just get bigger. It becomes unimaginable. There's a star so large, your brain will reject it. Its name is Betelgeuse. And it's not just big, it's collapsing. This red supergiant is hundreds of times larger than our sun. If it replaced our sun, its surface would stretch beyond Mars. Possibly even Jupiter. And that's when things changed. In 2019, it dimmed. Suddenly. Dramatically. Scientists thought, this is it. The explosion. A supernova. The moment a star dies so violently, it outshines entire galaxies. But it didn't happen. Not yet. And that's what makes it worse. Because it could still explode tomorrow. Or in 100,000 years. Which, on a cosmic scale, is basically the same thing. But here's the twist. Even Betelgeuse is nothing, because there's something bigger, much bigger, a star so large, it breaks comparison itself. Stevenson 2:18. If Earth were a tiny ball, this star would stretch for kilometers. Not meters, kilometers. You could fit billions of suns inside it. Billions. But that's not even the craziest part. If you tried to fly around it in a plane, it would take over 1,500 years just to go around once. So now ask yourself, if stars can reach this size, what happens when gravity wins? Because the next objects don't just grow, they consume everything. Black holes don't just exist, they dominate. And one of them changes everything. Ton 618. A name that sounds small, but hides something monstrous. This black hole is so large, its event horizon, the point of no return, is wider than our entire solar system. Let that sink in. Not the sun, not Jupiter, the entire system, gone inside it. But here's the strange part. It shines brighter than trillions of stars. Not because it produces light, but because it devours matter so violently, it glows. And that's when things changed. Because even Ton 618 isn't the biggest. There's something larger. Phoenix A. A black hole so massive, scientists don't fully understand how it formed. It may have been born directly from the Big Bang itself. But even that isn't the end. Because now we zoom out. Past stars. Past black holes. Into galaxies. The Milky Way alone stretches 100,000 light-years across. And yet, it's just one of billions. Then come structures so large, they shouldn't exist. Chains of galaxies. Walls stretching billions of light-years. And one of them, the Hercules Corona Borealis Great Wall, spans 10% of the entire observable universe. But here's the final question. If something that large exists, what's beyond it? And more importantly, are we really seeing the full picture? Or just the smallest corner of something far, far bigger?